calling one quantum physics. This must be it. This must be the chapter that they're serious about. It's all quantum physics. There's just different lists of topics in each of the chapters. So let's write down a few, what I think is basic ideas with quantum physics. Let's see. Let's do a comparison. Here's classical physics. In classical physics, we would take objects, we would analyze all the forces acting on them, we would find out what the accelerations were, and from that we would predict trajectories, right? We would say things like, I think of classical physics as in some ways kind of like projectile motion or something. If I know the properties of an object, here's an object that's got mass m, it's being launched at some speed v naught, and there's going to be some kind of a starting angle. Classical physics, what we would like to be able to do is come up with functions like these, right? Where is the object located as a function of time? And maybe how fast is it going? What are the forces acting on it? So there's a pretty well-defined trajectory in classical physics. And we want to be able to go in and determine that. And it comes from this. Everything starts with this formula. Okay? Everything derives from analyzing the forces, determining what the accelerations will be, and then using that to figure out what the motion of the object will be like. Quantum physics is pretty different. Quantum physics says that in place of a trajectory, what we're going to have something for a particle is its wave function. So particles have wave functions to them, and the wave functions are going to tell us everything we could possibly know. Not everything we'd want to know, but everything that we're allowed to know about a particular particle. So wave functions look like this. They have two properties. They have amplitudes and they have phase. Okay. And maybe an example of what we've seen with quantum physics, a good example here would be, go back and do our two-slit example that we looked at before. If I have a beam of particles and we send it through two slits, and then we look farther downstream to see where those particles are going to show up, what does the pattern look like? She said, well, it creates an interference pattern. So there's an interference pattern that develops from this. And how do we account for the presence of the interference pattern? Yeah, what we have to do is, in order to calculate the interference pattern, we have to look at wave properties of the particles. This is where we're going to get back to this wavelength question. Let's say this. Let's say I have a beam of electrons. All right? And the beam of electrons let's say that they have some amount of kinetic energy. Let's say, make something up here. I got a bunch of electrons, They got 20,000 eV. Each one of them has a kinetic energy of 20,000 eV. What's the wavelength and what's the frequency of those electrons? How would we determine wavelength? How would we determine frequency? Because those are the wave properties that we need to think about. Well, it turns out that frequency is equal to energy divided by Planck's constant. And wavelength for these electrons is going to be given by Planck's constant divided by momentum. So, what's the frequency going to be? Well, we could say that the energy is going to be equal to mc squared plus k. And plug that in. Take the energy we calculated here, divide by Planck's constant, and come up with a frequency. How are we going to come up with a wavelength? To find the wavelength, yeah, we got to find out what momentum is. How are we going to get momentum given the kinetic energy of this? Yeah, what we can do is we can say that momentum is equal to E squared minus mc squared to the half. So for a beam of electrons, we just need to know one piece of information, right? We need something to get us started. Once we know, in this case, how much kinetic energy they have, we can calculate total energy, we can use that to get frequency. We can figure out how much momentum it's got, we can use that to determine what the wavelength is. Now, one more shortcut here. When you're calculating wavelengths, it's going to be easier in most problems to calculate it as hc over pc. And the reason why is, what's hc? 1240. And what's pc? Well, pc is what we calculate right